Hey there, I'm Clifford Bates, and welcome once again to Basic Political Science Methods. Um, we're looking at Stephen Fenever's Guide to Methods and Study for Students of Political Science. We're looking at basic methods. So far, we're now at the stage of looking at Chapter 2. Within Chapter 2, looking at the case study of the approach. Why am I doing this? This is a thing that I normally teach a lot, and I think it'd be useful for those who want to do this of understanding these basic methodologies of what we do in this simple thing. I'm not. I'm going to follow. I use Evera because I think this is a good course for undergraduates and even graduate students concerned about how to do research and that's what do we do and how do we engage in it and how do we test and how do we validate things? How do we do what we do as political scientists? So today we're looking at how to create theories. With last video, we looked at the testing of theories, right? And basically the three fundamental styles of tests, which controlled comparisons, which are divided between congruence, methods of agreement, methods of difference, controlled congruence procedures type 1 and type 2 within case and across case and within case uh, uh, procedures type variants, then type and then process tracing. Right now, we're looking at generating theories, but also looking. We're going to be also addressing antecedent conditions, both the testing and doing of this. Now, case studies serve repeating the basic theory, right? Remember, case studies have these 5 reasons for doing it: testing theories, creating theories, identifying antecedent conditions, testing the importance of these antecedent conditions, and explaining cases, right? So, okay, we have this. We dealt with testing theories. Now we're going to be dealing with uh, uh, um, testing cases. Explaining cases of extrinsic importance. Right, that's 33. These purposes overlap, and several. For example, explaining cases and creating theories and testing theories, identifying and testing antecedent conditions, often can and should be pursued simultaneously. For another typology case study, see note 17, which we did, we talked about earlier in another video. So the previous session discussed theory testing, right? This section covers theory making. How do we make theories? And also we'll look at also testing sections here. We're going to be covering a couple sections here because otherwise this will be a very short video. Um, To infer new theories from cases, we start by searching cases for associations between phenomena and for testimony by people who directly experienced the case, actors in the case, for instance, on their motives and beliefs in the case. Therefore, we look at this. In other words, we look at to test and infer new theories. From cases, we start by searching cases for associations between phenomena. We look for testimony, people who are involved in it, right? And, and on their motives for belief for the case, right? These associations and participant accounts often clue on cause and effect. Then we ask, of what more general phenomena are these specific causes and effects examples? Okay, so in other words, we see these things. We ask, okay, of what more general phenomena? These specific things, these specific causes and effects are general. One candidate cause and effect are framed. Once a candidate is proposed cause and effect, candidate means the proposed cause and effect are framed. In general terms, the investigator has theories that can be tested against other evidence and applied to other cases, right? So we come up with a theory, generating a theory that can be applied to can be, in other words, we can test them to the case in question or to other cases, right? Once has been framed, and if the theories can be tested against other evidence, in other words, evidence, evidence that sometimes not. Again, this is the point. Can some evidence that you use to test it? Nah, remember the kind has to be certain things have to be, as a rule about what kind of evidence can be used, right? Um, Investigators can use 4 methods to infer theories. from case studies. Controlled comparisons, congruent procedures, and process tracing, all covered in the previous section, and Delphi methods. Now, the methods, Delphi methods are very interesting because we'll talk about this when we get to it, but it is its own term here, but it refers to going to the source. Delphi, going to the oracle. So going to this oracle, going to the source, the one who knows, right? So these are the four processes. Controlled comparisons, congruence procedures, process tracing, and Delphi methods, right? Congruence procedures compare observations across cases that infer theories. Congruence procedures and process tracing deduce theories from observations within cases. And Delphi methods consult the views of the case participants, okay? So this is what the four things are. This compares observations across cases to come up with theories. And congruence procedures and process tracing deduces theories from observations within a case. And then a Delphi method gets ideas from the participants, people who are involved in it, okay, sources. Start with controlled comparison. So therefore, if you ask what are the four methods, what are the things we do, there's four principal methods. That is controlled comparison, congruence procedures, process tracing, and Delphi methods. Right? So let's go look at them individually. Controlled comparison. In controlled comparison, the investigator infers hypotheses from contrast and similar in aspects of several cases, following Mill's methods of difference and agreement. In the methods of difference, the investigator explores several cases with similar characteristics and different values on the study variables. The variables whose cause or effect we seek to discover, right? Again, that's the study variable. The variable whose cause and effect we seek to discover, right? Looking for other differences between cases, right? That's method of difference. What other differences between similar cases but different things, looking for differences? These other cross-case variants are nominated as possible causes for the study variable if we seek to discover its cause, or possible effects if we seek effects. The investigator picks similar causes to reduce the number of candidates causes or effects that emerge, right? The more similar the cases, the fewer the candidate causes. This makes the real cause easier to spot, right? Number 35. For example, the method of difference. For example, of methods of different theory making, see note 25 to chapter 1, right? So you gave an example of that again. In method of agreement, the analyst explores cases with different characteristics of similar values on the study variable, looking for other similarities between cases. These similarities are nominated in candidate causes and effects as possible causes and effects for the variable. The method of difference is preferred when characteristics of available cases are homogeneous. So if the characteristics of available cases are all homogeneous, then method of difference is preferred. Most things about the causes most things about most cases are quite similar, right? That's what homogeneous means. Most things about this case. We have homogeneous cases, method of difference preferred. Methods of agreement preferred when characteristics of available cases are heterogeneous. Most things about most cases are different, right? So homogeneous means that there's most things about the cases are different, and homogeneous are most things about the cases are very similar, right? If the cases are homogeneous, methods of difference. If methods of everything if the characteristics of the cases are different, then you want method of agreement. Okay. Again, what you're trying to do is find possible ideas, possible variable. What looking for? Well, what is the cause of this? What is the cause of that? That's again theory. What causes this? What causes this? What is the cause of this? What does this cause? Okay. Either studying this, the independent variable. What causes this? What causes this to happen? If we're doing this, what does this do? What does it cause, right? So therefore, what does it cause? What does it do? So therefore, there are different reasons why we do things. And intermediate variables we look at, well, what causes this, and what does this cause, right? So again, this is the way we eject this method of agreement, method of difference aspects of trying to infer this idea. Congruence procedures. When looking at congruence procedures, the investigator explores a case looking for within case correlation between the study variable and the other phenomena. These phenomena are nominated as possible independent variables in new hypothesis if we seek to establish the study variable's causes, or a possible dependent variable if we're trying to establish its effects. So therefore, we're looking for either, in other words, we're looking at correlations of, we explore within case correlations between the study variable and other phenomena. And we're trying to decide whether this is the cause, or what is the causing thing of it, or what does this do? Okay, if you're studying the study variable is dependent variable, then what is causing it? You're trying to find the independent variable. If you're looking at what is this, you're looking at an acting variable. What does this do? What does this cause? Then you're looking for possible causal dependent variables, right? And he says that let's do this right. He says that we possible. In other words, of this, three specific formats are used. So three formats of congruence procedures are done. So of these congruence procedures, we're looking at within case. So he says, looking at mostly within case, right? Again, I think this is correct, within case. Yeah, for within case correlations. We're looking for within case correlations, right? So one, examine outlier. The investigator examine outliers, exploring cases that are poorly explained by known causes, on the assumption that unknown causes explain their outcomes. So look at outlier cases. Okay? Specifically, the investigator looks for cases where the study phenomena is present, but its known causes are absent. So available phenomena is therefore that you have a phenomena, but what causes this is not known. Still undiscovered causes must explain the phenomena. These causal phenomena should be observed in above normal amounts in the case, and should be observed conveying with the study variable. Now, this is 36. Studies of outlier cases are known as deviant case studies, like Leipart. The logic of studying outliers follow the logic of John Stuart Mill's method of residues. On this, see Mill's system of logic, this discussion of method of residuals, right? So that's one, right? We look at investigate outliers. Two, the investigator selects cases with extreme high or low values on the study variable and explores them for other phenomena that are present in above normal or below normal amounts. So in the case, we look at the study variable, pick the study variable that has, or a case that has a situation that has above high normal, below normal values on it. And then what you look for things that have either above normal and below normal amounts. When the study phenomena is present in abundance, its cause and effect should be present in unusual abundance and so stand out against the case background. When the study phenomena is absent, its cause and effect should be prominent in their absence, conspicuous by its absence. Right. So therefore, again, if it's present, you should see it. It should be if it's highly present, it should be the thing that's causing it should be highly present. If it is absent, then the thing that causes it should be as equally absent. Okay. Number three, investigators select cases with extreme within case variance on the dependent variable. So a case that has an extreme variation in dependent variable and explores them for looking for phenomena that covary, in other words, that varying in the same way in the study variable, with the study variable. So we're looking at a dependent variable, right? Within case on a dependent variable. And this is the study variable in that sense. And then with an extreme case, right? And that therefore there should be an extreme covariance in this. If values on the study variable vary sharply, its cause and effect should go also vary sharply. In other words, this thing varies sharply. It either goes like, it varies sharply. That covaries with the study variable. If the values on the study variable vary sharply, change sharply, its cause and effect should also vary sharply, standing out in the more static against the more static case background. So therefore, in other words, if this is, you're studying and says this, then I can see that this is. So therefore, that's why extreme case variance and on the dependent variable. Okay, the dependent variable that's the study variable we're studying that has extreme case variance, and therefore we should see the effects. Now, that's congruence procedures, and there's the three methods of congruence procedures. Process tracing, the investigator traces backwards the causal process. Now, he traces backwards, right? That produces the case outcome, each stage inferring from the context what caused each cause. If this backward process trace succeeds, it leads to the investigator back to the prime cause. And this is what we're looking for. In other words, we look at an outcome and we try to look at, well, what we go backwards. We follow the process backwards. This is how we, in other words, generate theories, right? This is taking a traces. Investigator traces backward this process, right? So if we get an outcome, we look at an outcome, and then so how did this occur? And then look at the process, how this occurred, and see if this process then is repeatable. In other words, does the evidence support that this is the outcome that happened because of this? That's how you test it, but this is how you generate it. Or now, last but not least, Delphi methods. In Delphi methods, the investigator mines the views of case participants and others who experienced the case for hypothesis. Those who experience a case often observe important unrecorded data that is lost to other investigators. In other words, you get a lot of data. You get data that is recorded and that is lost to other investigators, right? The primary people. An investigator uses their memories and judgments to infer hypotheses that could not be made from direct observation alone. Now, 37. For example, Delphi methods theory making, see Chapter 1, Note 27. Delphi method does not have much stature as a method for testing theories or explanation, partly because Delphi methods expert process cannot be replicated. In other words, they're not replicated. They are their opinion. They're from the journal. It's one person's opinion. In other words, Delphi methods are not useful for testing. They're not really good for testing. You cannot use Delphi methods to test. You can use Delphi methods to generate hypotheses. The information that you generate from Delphi methods are usually, you're trying to for their opinions, their beliefs, and why they'd happen. Now, there's a difference between, this is the question everyone says, when can you use, this is a question about evidence, right? When could you use evidence from journals as something to test? Well, it depends. What are you testing? If you're testing a general theory about something, this is an only individual case. This might be objective. This might not be reflective opinion about this. So, but it can be used to come up with ideas, but it cannot be used to test it. But if the thing I'm talking about is elite opinion, elite belief about a policy decision makers, I'm looking at the question of decision makers and the why they made the decision, right? Well, I'm not looking at the general question of why this happened. I'm looking at why these people did it. And if this guy is one, if the person's diary I'm looking at, or the biography I'm looking at, gives me evidence about that one person, well, then I have evidence from one case. Now, if I'm going to make a general thing, of course I can't generalize. I have to go look at other actors or decision makers in that same instance, and see what they say, and is there agreement between the cases? And if there's agreement between the cases, then we have a situation where if I have like 10 or 20 of the key actors, and if I look at this and I say there's 30 key actors who are in this decision. If we look at this debate or this process in history or this policy issue, we look at that and then we go check like a congressional thing. I want to understand why back in time the Congress people did it, right? And I think I'm going to make an argument about psychology or about their individual decision. Well, I have to go look at everyone's. If I have to go see the ones now. Not everyone is going to have these congressmen are going to keep diaries. Some of the congressmen will have papers and records. Others won't. You have to go check their records, and therefore you can go check the records and find it. You see look at the event at the time and see their biographies, their records, their papers, to see if they mention something. And if they mention this and then you go to several, you find like a dozen other people who have the same thing, then you have a kind of correlation. You can keep on doing it, but at a certain time, if you have, let's say you have a situation, you take a sample, let's say you have 435 and I do 25 things and I got 25 out of all 20 out of 25, 20 out of 25 people say that this was an issue. This, as long as I'm not biased, I could keep on going, and if that ratio stays the same, then I can basically say, if it's like I start at 10 and it's like 8 out of 10, then I do 10 more out of 20. There is 12 or 13 out of 20, and then at 50, there's 40 out of, you're saying you keep on going, and that the ratio and the percentage is about the same of what the people saying that versus not saying that. Then you can basically claim, well, maybe that's the reason, right? If a significant number of the cases doing it, saying it, and you don't necessarily have to get everyone, but of course, not everyone's going to be there. If there's of the cases of the available things, you look at that and you look at a process. You're going to say the argument is that something that was noticeable was simply only noticed by those who did it. Would suggest, the people who did do it, and if they mostly all recognize it, then probably everyone would have recognized it. If only one or two among the people who did it, then it's probably not relevant. But if the majority or the almost all of those who recorded something record it, the question is then, what happens when? So it's a question of proportion and reasonableness. So therefore, that's why Delphi methods are very kind of a tough thing, because that's why you can't always use Delphi methods to test. And this is why these personal diaries and these things are problematic. Depends on what you're trying to do with it. I'm going to get one person's story, one person's account to say about the whole thing. No, that's generalizing from one case. That's invalid. This doesn't. So what is test evidence from one case is not evidence that can be shown to prove a whole thing. It's only validating one person's reality, one person's things. But if this person and other people like them are tested and they say the same things, now it becomes a question of percentage. What percentage of this and what percentage of that? Do they say exactly the same thing? Is their experience identical? Now, this is the thing. This is what we have opinion polls and surveys, but even opinion polls and surveys are problematic these days because not everyone participates, and some people participate, and some people lie in the surveys. Okay, so that's this is one of the problems of Delphi methods is why we can't rely on it, and this is the question of evidence. You can only test with things that we consider as valid evidence. And the valid sources that can be used as evidentiary sources. Okay, now let's go to the next thing. If we talked about creating theories, now we're going to be inferring antecedent conditions from case studies. Now, this is what inferring means: coming up with ideas about antecedent conditions from case studies. As noted above, the weakness of the SQL case study is the concealing of theory is the concealment of theories antecedent conditions. The background conditions required for theories that operate or magnify their action. However, one can uncover these background conditions by examining selected new cases, right? So you can do this in this sense. In other words, even though you can't find, in other words, it doesn't show antecedent conditions. Case studies are not good at revealing what antecedent conditions are. Ironically, you can use case studies to generate an antecedent condition. Okay. Now, he says 4 methods for inferring antecedent conditions are most useful. These methods parallel the 4 methods of inferring theories outlined above. So again, they parallel parallel the methods of theory inferring. So inferring of antecedent conditions and theory, creating theories, inferring. Inferring also means creating. Creating theories, inferring antecedent conditions, or generating antecedent conditions are what? Are parallel to each other in these methods, in this sense. Controlled comparisons. 1. Controlled comparisons. The investigator uses methods of difference to infer antecedent conditions from contrasts or similarities in the characteristics of several cases, right? Methods of agreement is too weak to bother with. In other words, the method of agreement is too weak to bother with here. So therefore, the only method of agreement, in this case, only method of difference. Okay, that you look for antecedent conditions that contrast similarities in cases of each other, right? Similarly, the investigator selects and examines new cases that resemble previously studied cases in all ways, except their value on the dependent variable. For example, if previous examined cases had high values on the dependent variable, we would now examine cases with high values on the IV and low values on the DV, and a close remembrance to the previously examined cases in this regard, right? So therefore, we should control in the sense, again, this is that one sentence here, right? For example, if previous examined cases had high values on the independent variable, we should now examine cases with high values on the independent variables, low values on the dependent variable, and a close resemblance to the previous examined cases in other regards. Thus, if the hypothesis that economic downturns cause trade closure, having been tested using Europe 1929-1939 as a case, high values on the IV and DV, we would next look for cases when downturns occurred without closures. If we can find no high IV, low IV cases, this suggests that the conditions required for the theory's operation are abundant, and the theory has broad theory has broadly applicated or external validity, has broad applicability and external validity, right? In other words, if the theory are abundant, then the theory has broadly. If we find such cases, we inspect them for points of difference with previous examined cases. Important antecedent conditions will appear as points of cross-case difference. So therefore, there will be differences. They will show up different. In other words, if there is situation to similar cases, right? In other words, if we find such cases, then we inspect them for points of difference with previous examination. And then what happens is the important antecedent conditions will appear as these points of cross-reference difference. Now, congruence procedures. Congruence procedures, the investigator measures the gap between the predicted and observed values on the dependent variables, and in a case, then looks for correlations between the size of the gaps and the values on the phenomena within the case. So therefore, how big are the gaps and the values on other phenomena in this case? So therefore, we look at what? We investigate the gap between the predicted and observed values on the dependent variables, right? The predicted value and what is the gap between it, right? And then look for correlations between the size of the gap and the values to other phenomena in the case, right? Things that have this. The investigator then nominates phenomena that correlate with the gap. that are scarce when the value on the dv is lower than the iv. In other words, that are scarce when the value on the dependent variable is lower than the independent variable value warrants, and are abundant when the dependent variable value is higher than the iv value warrants as possible antecedent conditions. He says now this, right? This one situation, two formats I used. The investigator can examine outliers, those cases where theory posits cause is present, but is but its predicted effect. In other words, this cause is present. The positive theory cause is present, but its predicted effect is absent. If we assume that the theory is valid, this pattern indicates that an important antecedent condition is also notably absent, right? If there was an antecedent. The missing antecedent condition may be identified among conditions that are often present but are absent in the outlier case. Or the opposite happen, that we know that this theory has it, but then it doesn't happen. This doesn't happen. So therefore the antecedent condition may be absent, right? So therefore it's something, if in a theory where the antecedent condition is required, that there's, but then it doesn't happen, you notice that the antecedent is absent. That's okay, that's the idea. That's a test, right? We're looking at something and then we see it not happening. We're trying to discover an antecedent. We're not trying to test the antecedent condition, right? So outliers in this case, right? The missing antecedent conditions can be identified among the conditions that are often present but are absent in the outlier cases, right? They're present. They're obviously there in the. They're obviously present in the normal cases, but in other words, the missing antecedent conditions can be identified among conditions that are often present but are absent in the outlier cases, right? In that sense, okay. So the investigator can also explore cases with large within case variance on the value on the dependent variable. So if there's a big thing, and high constant values on the independent. So high within case variance in the value of and the dependent variable. So that's okay, and constant high values on the independent variable. This pattern suggests that important antecedent condition varies within the case. This pattern may also occur solely because of variance in the value of other variables that cause the dependent variable. So therefore, again, there might be intervening variables that could be causing that as well, right? So so again, just within case variance on the dependent variable and constant high values of the independent variable, this pattern suggests that the important antecedent conditions vary within the case. It should announce itself as a factor that covaries, that has varying. Covary means something is varying, means changing. And these things are changing in the same way. They're both changing with the dv. These things are changing with the dependent variable. So that's the two ways of process. Congruence procedures. They're both, I suspect, they're both what one is the outliers, and therefore outliers again, where cases of this are predicted. In other words, so outliers, right? Outliers. Again, I think this is within case variance, right? Yeah, it's within case variance. It's type 2, I think. Multiple within case variance. It doesn't say. So congruence procedure investigate measures gaps between observed variable and dependent variables and size of gaps between these things. So that's there. And we say outliers, and then yeah, this is outliers cross case, and the investigator can also explore cases within large with cases with large within case variance. So that's type 2, right? Type 2 approach style, right? And he says that this should announce itself as the factor that conveys with the dependent variable, right? Now this leads us to the third. That's the second thing, congruence practices, where there's two types, two formats, right? Now, process tracing is, again, like process tracing happens with creating theories. The investigator traces backwards the causal process by which the case outcome was produced. At each stage, attempting to infer from the context what antecedent conditions the process requires. Right. So look at this. What is there? What? Okay. Look at it. This process and what this. Go backwards, and then as we go backwards, we then look at this and what is this? What antecedent conditions or factors would cause this? This needs what to do this. Okay. That's what process tracing does. Take the process going backwards, inferring from the context what antecedent conditions the process requires. And last, Delphi methods. The investigator mines the views of case participants with others who experience the case for possible antecedent conditions. They may observe in person. They may observe in personal telltale dynamics that cannot be observed in retrospect by non-participants. So again, look at the Delphi method. So Delphi method, you look at it, they may see something that happened at the time, and that they may recognize something that other people, non-participants, would not have noticed or recognized. Okay, again, that is Delphi methods, and those are the four. Now, here we come to the problem of testing antecedent cases. Antecedent conditions, like hypotheses, should be tested before they are lent credibility, right? So then once you get you come up with once we generate one, before we say it's okay, we have to test it. And it's like a hypothesis, right? Should be tested before they lent credibility. Like hypotheses, they can be tested three ways: controlled comparison, congruence procedures, and process tracing. So let's go controlled comparisons, the first type. Controlled comparisons. The investigator explores paired observations in two or more cases, asking if values on the pairs are congruent or incongruent with the premise that the antecedent condition magnifies the causal action of the independent variable on the dependent variable. Okay, right? So therefore, in other words, we're looking at this. So therefore, we're saying this hits this to make that do something. This causes this to do that, right? So therefore, what we should do, we should ask if the pair is the pair of the congruent and non-congruent with the premise of the antecedent condition. So we look at cases where this is present, this on this is present, and this is present, this, that, versus this and this present, but that is not present. Is the effect here the same? If there's no difference between, we say this and this causing this, and the effect here on this is the same if that is present or not, then we have oh my God, we're still doing things. Did I not turn it off? Did I not do it right in the first place? Uh-oh, there might be a problem here. Okay, let's see this. What did I do wrong? Maybe I didn't do something. Uh-oh. Okay, signing off.